I find this certain particular fascinating question which my student sent to me, and I want to make some little explanation on that. This is actually a jam question, very simple and clear, but the problem is about tactics. Now, this question says that the driver in a motor car, of which the total mass is 800 kilogram, either of the car and the driver, 800 kilogram, and which the car, the driver is actually inside the car and the car can be traveling itself. So the at which is actually traveling at 20 meter per seconds. You can see there's one important thing that students do skip when it comes to calculation is notation of comma, full stop. These things are very important when you are explaining some things or for you to understand some concept of explanation. Very, very important. Now it says that suddenly the driver literally observed a dog, a stationary dog. Stationary means the dog is not moving. Maybe it is dead or the elekwaya have kolo for we don't know. So, but the dog is actually not moving. Is stationary, and he saw it in his path, but it was 50 meter ahead. That means practically that it actually see the dog 50 meter ahead. But don't forget that the car is actually not just moving with a mere velocity. It's actually moving at 20 meter per seconds. It is actually on move. I get what I'm saying. So, but it literally sighted it 50 meter away. And the point now tell us that if the car brake can exert a force of 200 Newton, we are being given an assumption. What will most likely happen? Now, there's something we have to talk about that physics will deals much more with a calculation of the result that will yield what we call a true and explainable scenario. So if you are telling me that the car will be able to stop immediately, the driver noticed the dog. This can be bullshit. Do you want to know why? Is that you telling me that the car will be able to stop immediately? This is just an assumption. What if the car does not stop? There's nothing to qualify for that. So at that point, when you cite some answers, you would have literally know your problem has get reduced little by little. Are you get what I'm saying? Now at this point, now we are left with this saying the car will stop 30 meter. How do you want to know? That means that we need something that involve distance. The car will stop 20 meter. Also the same thing. That means that at this point we are left with B, C, and E. Those are like the sure plug question that we need because some calculation is involved. Now this details us that the driver will quickly reverse the car. This is also bullshit. What are you telling me? How can he quickly reverse the car when the car is actually on move? Are you getting the logic? So you can't expect a person to literally suddenly reverse a car after applying some brake, then reverse instantly back. So this is also bullshit. At that point, you are left with three answers to clarify your doubts. And if you are looking at these three answers, there's only something that can help us is calculation. And you are not just given some parameters for joke or just for fashion. They are there for you to understand some concepts you need to deal with. And let's go back to the question being said. It says, don't mind my dog, don't mind my car. So it says that the driver actually in a motor car of which is actually has a particular mass of 800 kilogram, right? And it is traveling at 20 meter per seconds. And suddenly you apply a brake of 200 Newton, a force on it. But nevertheless, he actually sighted the dog which was at rest 50 meter. Abby. Now at this point now, what we want to know is from what we are being given our parameters, we are literally looking at for that car to be in motion. That means that we are literally looking at something under equation of motion, and it can't be Newton's first law, neither will it be Newton's third law. It has to be from Newton's second law of motion, and that is from our what? Our force being equals to the change in the linear momentum over time. And don't forget that, or we can also say change in time majorly, but let's just put our normal time. Now, don't forget also that the same way we are utilizing this, we also could remember that from the breaking down of this, that was where we got F equals to MA. I'm not here to break any formula down. So from our F equals to the M change in V over, we can say T majorly. How you get what I'm saying? Then from there, you can have F equals to M change in V over change in T, where this will give us MA. Okay, but I'm not really less concerned about that. What we are much more focused on is how to solve our problem. Now, first and foremost, we need to find at this force that is applied and at this certain particular mass. First and foremost, we need to find the acceleration at which the body is moving. Are you getting my logic? Or that's if you want to do it this way, that's dealing with F equals to this one, let me say m change in v over t. Now, this one I can say F equals to ma for the second method. I can find the acceleration. So when I find the acceleration, I would be able to utilize it in finding the distance that the car itself will cover with respect to this force. So if I am to know the distance that car will cover, that will make me do my estimates to know what will happen or the scenario that will occur between that two places. Are you getting the logic? But from here, majorly, first and foremost, I can also find my time. If I'm to find my time also, I can use the time in a certain particular equation of motion to also find the distance. So any of the two formula I'm using is still the same thing. So from here now, if I'm to deal with m change in v, if I'm to cross multiply here, I have my time being equals to, my mass is 800, then the velocity is 20 over the force, which is 2000. I have 0 cancel 0, 0 cancel 0, 0 cancel 0, 2 cancel 2. So my time being 8 seconds. Are you getting my logic? So for me to get the distance that the body cover, I can use v square equals to u square plus 2as. Okay, I think I'll use this one for here. Now let me also calculate the same something here now. Now if f is equals to ma, from here now you know our acceleration will be equals to f over m, and that will be 2000 over 800. So from there we have 0 cancel 0. 20 divided by 8, automatically we should have a equals to 2.5 meter per second square. Are you with me? So either we can utilize it, you can see the way we are breaking it down so as to make things easier for ourselves. So at this point now, we've gotten the time it utilized, we've gotten the acceleration that the body is moving with. So from there, we can use either v equals to, we can use our s equals to v plus u over 2 times t. Are you getting me? So we can use our v equals to u plus v plus u over t, or we can majorly use what do they call it, v square equals to u square plus 2as. Any of the two you utilize there, it's a go, we work. So I want to use the short one so as not to waste time. So at that point, I'll have s equals to, and automatically our u practically will be starting from rest. So since the body is still moving at a normal constant velocity, we have 20 plus 0 over 2 times, our time is what, 8 seconds. 2 in this one, 2 in this, you have 4. So our x will be equals to 20 times 4, and that will be equals to what? That will give us 80. Now you get what I'm saying? And from this point, we have this. Okay, so, and majorly also, though, if I'm to utilize the normal equation of motion, our normal formula from here, we still have the same value for distance. So since our distance is 80 meter, that means that the car, even at that brake that is applied to it, the car from that point at which it wants to move, at that point they apply the brake instantly, it will still cover 80 meter, which means that it will it will eat the, I am saying it will eat the dog, because at that point that brake won't be able to cover that distance easily. So it's covering 80 meter. If you are to look at the options they gave us here at this point, it says the car will stop 20 meter in front of the dog. This is wrong because it has even surpassed the distance of the dog. This, the E says the car will stop 5 meter beyond the dog. Now if you are looking at now, this is 80 meter. 80 minus 50, that means it is stopping 30 meter away from even the dog itself, which means also this the car will stop 5 meter is also wrong. So if you are looking at the answer that will be correct, probably that will be what? That will be B, because the car will stop 30 meter, and that is our 30 meter you can see here. 30 meter, 80 minus 50, that's 30 meter. It will stop 30 meter after, you get what I'm saying, after it has hit the dog. So that is the logic behind the question. And can you see how simple it is? So that's just it.